Okay, guys, looking at today, we're going to kind of build on some of the concepts we talked about yesterday. But today we're looking at how angles are formed between secants and tangents, and how we use that relationship and go forward. At this point in time, I want you guys to please take out your Ames reference sheet. All the formulas I'm going to give you today are right on those sheets. Okay, so please get out those sheets. So our objectives today are very simple. These are called power theorems. So we're going to learn how to manipulate the power theorems to solve for angle and segment relationships. The segment relationships will be tomorrow. So today we're just looking at the angles. What I'd like to do with you guys is maybe just do a little bit of quick review on some basic vocabulary that you'll need to know for this section of the unit. So what is a tangent line? We talked about that yesterday. What makes something a tangent? Connor?
When there's only one outside.
And intersects a circle exactly once. Okay, very good. So write that down. So a tangent intersects the circle. Keyword here is exactly once. Not less than once, not more than once. Exactly once. Alright, so our tangent line going through A, right there. Now, did you guys see point A? That's what we would call the point of tangency. So the point of tangency is where the tangent line intersects the circle. The point of tangency is where the tangent line intersects the circle. For those of you guys who are interested in when am I ever going to use this, and maybe most of you guys are not, but for those of you guys who might see yourselves going on into further mathematics, the tangent line is extremely important when we talk about curves because it gives you an instantaneous rate of change at that point. So if you can imagine taking a pair of keys and swirling them around in a circle, the tangent line at any given time will give you how fast those keys are moving and in what direction at that moment in time. So when we think about a circular path, think about anything just traveling around in a circle. For those of you guys who love NASCAR,
It's an oval, alright.
it's 4 left turns. Alright, so yeah, but that's not NASCAR.
Also, don't forget that.
So, oh,
There's
sorry.
there are 3 straights.
Either way, I guess they still merge to the left. Alright, so
It's an easy spot, or it's an easy sport to follow.
yeah, pretty much. Don't think you involved. But alright, my brother was a big NASCAR fan. I can't stand watching the race. I don't think.
I just watched it.
First of all, really, that is like the one sport where nothing matters until the last 2 minutes of the race. Why do you sit there and watch it for 3 hours?
To see how many people back can get into it.
Exactly.
If you want to watch that, go to a hockey game.
It's just fights.
That's
It's
why I
not
watched
like-
Talladega.
Ah.
That's what I watched.
Did
All right.
you see when the car drove into the boat?
That was
good.
Okay, here we go. Next, I want to talk about something called a secant line. A secant line intersects a circle not once, but twice. So you can imagine a line that goes through B and C. We would call that the secant. So it's just some basic definition I want you guys to realize. Secants intersect twice. And tangents intersect once. Now there's one more piece of information I'm going to throw in here. We don't really talk about much in this unit, but it's worth mentioning. If I take my entire secant and take just the portion that's inside the circle, call that a chord.
Chord.
Restate that.
It's the portion of the secant that's inside the circle. Call that the chord. All right, now let's actually get into the meat of today's lesson. When we think about two lines intersecting with a circle, we have three outcomes. All right? You can intersect inside the circle, intersect on the circle, or intersect outside the circle. Correct? Yep. And on and on. Very good. Now, think of it as a circle of friends. No, honestly, think of it as a circle of friends. Is it good to be within your circle of friends?
Yes.
Yes, for positive, right? In general, for positive to be within the circle, be in the know, right? So when we think about an intersection inside the circle, the angle formed by those two secants is half, just like what they described, it's half the sum of the arcs. Half the sum of the arc. If I'm on the circle, this is what we learned yesterday. If I'm on the circle, it's what?
Half the measure of the arc.
It's half the measure of the arc. Oh, but hold on here. That's the same formula. That's completely different from yesterday. Now, this is where I want you guys to stop and think for a moment. I don't want you guys to memorize all these different formulas. Memorize one and be able to manipulate it. This is the same formula. Yesterday we learned that the measure of angle x is half of arc AB. But today I told you we've only got CD to contend with. Connor? There's no CD, so what's the measure of CD? 0. What's AD plus 0? Measure of AD. It's the same formula. It's just been adapted because of where the point is. Okay, so if you're in or on the circle, it's half the sum of the arcs. Now, it's kind of a bad thing to be outside the circle, right? You don't really get to see what's going on and you can hear what's going on. So the only difference there between being inside versus outside is it's half the difference of the arcs. You subtract the arcs rather than add them. Okay, now this concept right here, we actually have three different outcomes for that. How many different ways can we intersect outside the circle? And that's what the whole next slide's about. So we have three ways we can intersect outside the circle.